Hello everyone, this is Sanjay Mittal. I teach at the Aerospace Engineering IIT Kanpur, and I will be introducing this course on fluid mechanics to you. So, let us first look at some of the applications of fluid mechanics. As an aerospace engineer, if you want to design airplanes, then one would like to estimate what is the size of the wing that is needed to fly the airplane, what is the size of engines that are needed to fly the airplane, and the lift and drag calculations from fluid mechanics can give us that estimate. Same thing for a parachute. If I want to design a parachute that brings me down carefully, safely, then I want to estimate what is the design of the parachute that is needed, and for that I need to know what is the drag that acts as the parachute comes down. How about if I want to design a dam to store water? Then I need to design a strong structure, and my concepts of fluid mechanics will tell me what is the force acting on this structure because of the storage of the water. And then if I want to extract energy out of the stored water, for example, let us say in terms of electricity, the fluid mechanics can help me design equipment like the turbines and so on. If I want to design bridges that are safe and do not vibrate in maybe breeze or even in storms, then I want to make sure that the bridges are strong enough, and I want to estimate what are the forces acting on these structures. So, you would see a picture of the Tacoma Narrows Bridge, where there was a breeze and it kind of failed because it went through these galloping oscillations. How about human body? If we want to design, let us say stents, where we want to look at what for a bypass surgery, or if we want to design even an artificial heart, then the flow of blood through the body will help us in designing these things. We can also use information of fluid mechanics to design ventilator systems for patients who have problems with their lungs, or maybe dialysis machines where patients have problems with their kidneys, or even things like how do you transport drugs to the necessary parts of the body in an appropriate time frame depending on the body weight and so on. Also, you see here a picture of a face mask which was used so often during COVID. So, what is the fluid mechanical effect of a fluid mask? How does it prevent the flow of bacteria, the transmission of bacteria from one person to the other and so on. How about a washing machine? All of us know that a washing machine agitates the flow so that the dirt can come out of it. So, how do you design an agitator that is most effective, uses the least amount of water and of course, the least amount of electricity? Sports, that is again another area where fluid mechanics can be understood very effectively. If you want to design badminton shuttlecocks to replace duck feather shuttlecocks, or if you want to win, let us say, a race where I am a cyclist in an Olympic and I want to find out how far downstream I should be upstream cyclist, fluid mechanics can help me. Swing of a cricket ball or its reverse swing. If I am trying to perfect my strokes in swimming, again fluid mechanics can help me, or understand the knuckleball phenomena of a football. Formula motor sports. How do I design the wings, the nose cone, the air intakes of these very nice sports objects? Fluid mechanics can help me with that. You must have looked at the flow through a faucet, maybe in a kitchen. So, when the volume flow rate is small, then you get a very nice stream of a jet that comes out of the faucet, and that is a laminar flow. But then as you increase the flow rate, then the water gurgles out of the faucet and you get what is called as a turbulent flow. So, we would like to characterize that and perhaps use that to an advantage. Same thing for bluff bodies. If I have a boundary layer, I can talk about the laminar flow over a bluff body or a turbulent flow and then use that to my advantage. Can we use that advantage to design bodies? So, here is an example of a streamlined body and another example of a bluff body where the flow is hugely separated. Now, from an engineering point of view, this is very important because streamlined bodies will have much less drag or air resistance compared to a bluff body. In fact, in modern cycles, these concepts are used very effectively. So, shown here is a bicycle where the handlebars, their droops is engineered so that you have a reduction in drag because of the posture. Then you have the helmet which is designed so that the drag is minimal. For example, the rear wheel would be solid and so on and so forth. So, let us see what we are going to do in this course to understand these concepts. So, we will start by assuming that the flow is a continuum, and we will look at the concept of properties. Then we will look at a stationary fluid, that is called statics. Then we look at moving fluid and understand the kinematics of fluid elements. We understand concepts like rotation, strain rate. Most of the balance laws, they are designed for control mass systems, but in fluid mechanics we look at control volume systems. So, we are going to talk about a Reynolds transport theorem, which tells us how we go from a control mass to a control volume analysis. Then we formulate the balance laws for these systems. We also look at similitude and modeling. So, if I want to do wind tunnel testing or even free flight testing of objects, then what are the principles that I must be kind of looking at to make these testing effective. Then we look at other examples like pipe flow. So, if I want to pump water, let us say from a main storage tank in the city to your house, then what is the power of the pump that I will need for the network of the pipe flow. So, maybe those concepts will be useful in designing that. Then we look at other aspects like low Reynolds number flows, high Reynolds number flows, how we can approximate the high Reynolds number flows with a boundary layer approximation, go to the concept of a streamlined and a pluff body, look at again laminar and turbulent flows, and then look at all these concepts in totality to certain applications. For example, how is lift generated in airplanes, or for example, how does a cricket ball swing or reverse swing, or maybe go through a knuckleball and some such effects. So, hopefully you will enjoy this course. Thank you very much.